Okay, Billy, could you tell me how to get to the grocery store from our house? Well, let's see. You're going to start by turning right onto Taylor Road once you get out of the house. Then Taylor Road, you're going to go and you're going to take a left at Mulberry Street. Keep going on Mulberry Street until you get up to, that's Mallard Drive. So you turn left onto Mallard Drive. And then from there, the grocery store is on the left. So that's right, left, left, left. Good. Now I need you to get back home from the grocery store. Hello, Mathemaniacs. I'm the Math Edumacator. And no, we didn't switch to geography education today. We're going to be talking about something called inverse operations. We established in our numbers series that arithmetic is formed of two different pillars, numbers and operations. Numbers are things or quantities that you have, and operations are what you do with those things. If we were to use a grammar analogy, then numbers would be like nouns and operations would be like verbs. So operations change numbers. If you start at a certain number and you perform operations on it, like addition, subtraction, multiplication, division, then that will change the number. It'll either get bigger or smaller, and eventually it'll end up somewhere else. Kind of like the example we did in our intro of going from your home to the grocery store. However, once your journey is complete, what if you want to get back to where you started from? Again, to use our grocery store analogy, that's like trying to get back home after you've gotten to the grocery store and gotten your groceries and all that. The way you do this is with something called inverse operations, which are very important for the next major domain that we're going to talk about in this series, which I don't want to give away what it is just yet, but it does rhyme with algebra. So, the key thing to remember about inverse operations: if you perform an operation and then perform the inverse of that operation, you'll end up undoing the first one, so you'll end up right back where you started. We've already done a little bit of this in some of our other videos. For example, the inverse of addition is subtraction. So, say I started with the number 5. If I then added 4 to 5, then I would get 9. Now suppose I want to get back to 5. What I need to do is subtract that 4. If I start at 5, the addition brings it up, and then the subtraction brings it back down. So where we end up is right at 5 again. Now, inverses work both ways. Just like subtraction is the inverse of addition, addition is the inverse of subtraction. So if we again started at 5, but this time we subtracted 2, now the way we get back to 5 is we have to add 2. So we start at 5, the subtraction brings it down to 3, and then the addition brings it back up to 5. Likewise, multiplication and division are inverse operations as well. If I started at 10, then multiply by 2, I'd have 20. I could divide by 2 to get back to 10. Or, if you want to go the other way around, if I start at 10, I could divide by 2 to get 5. And then I could multiply by 2 to get back to 10. These are just a few examples based on the operations we're most familiar with. There are actually many more. For example, Billy has another example of something like an inverse operation. Yeah, come on up. Come on up. Don't be shy. All right. So, what I want you to do is, first off, everyone notice Billy is facing this way, to the right of you. All right. So, Billy, what I want you to do is I want you to turn around. Okay. So now he's facing the other way. He's changed. And now I want you to turn around again. Right? So, he turned around, and they turned around a second time. So, he effectively undid what he did before. So, he did an example of an inverse operation. Thank you. So, we can think of analogies to inverse operations in spatial terms. That is, if I perform some action, I can usually perform another action to undo what I did the first time. For example, I could step to my right, and then if I step to my left, I will effectively undid the action that I just took, because I'm right back where I started. Now, it's important to note that not every action can be undone. For example, if I ate the starburst, then I would not be able to uneat the starburst. I wouldn't be able to undo that action. And this is true in math as well. There are some examples of operations that you can't undo exactly. But for the most part, we're not going to be talking about those, at least not right now. Now, when we combine operations to take our numbers on a more complicated journey, the inverses we come up with to undo that must also become a little more complicated. So to really tackle the notion of inverse operations for more complicated journeys, we're going to go back to our original grocery store. So remember, the way that we got to the grocery store was we turned right, then left, then left, then left. So now picture trying to work in reverse. We're going to undo each of those steps individually. Which step are we going to undo first? Well, considering that we're at the grocery store trying to get back home, the step we'd have to undo first would be the one that we took getting into the grocery store. So this turn right here. So we have to turn right out there. So we're effectively undoing our last step. And that's the key. You're going to undo all the steps in the reverse order that you originally did them. So we're going to make a right turn here to undo that step, then right turn here, then right turn there, then a left turn there. So in this example, the inverse of right, left, left, left is right, 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 left. So if you have a more complicated set of operations that you have to undo, remember that the key is order of operations in reverse. So let's put this idea into action. We start with 10. Then we subtract 3. Then that whole quantity, the 10 minus 3, we multiply it by 5. Then we add 4. All right? So 3 operations. It's kind of a complicated journey. So how do we undo it? Basically, we retrace our steps, starting at the end and working our way backwards. First, we subtract 4 to undo that addition. Then, we divide by 5 to undo the multiplication. Then finally, we add 3 to undo the subtraction. And so where do we end up? Right back at 10. Now, as I stated before, there are other operations that have inverses, and we'll talk about them more some other time. But the principle is still the same. If you perform an operation and then perform its inverse, you'll end up right back where you started. And that's it for today's video. We're on our school year schedule now, so videos will be out every 2 weeks instead of every week. Tune in 2 weeks as we dive into our next major mathematical domain, the world of algebra. Thank you for watching. If you enjoyed this week's video, please like, comment below, and share the link. If you want to see more, subscribe to our official YouTube channel and follow us on Twitter at Edumacator.